Hello student, welcome to our lesson today. In this lesson, we are going to look at frictional forces. We start with the definition. Now, the frictional force refers to the force that opposes or tends to oppose relative motion between two surfaces in contact. Now, frictional force is a contact force. That is, it exists between two surfaces that are in contact. Now, the frictional force always acts in the opposite direction to that of the pulling force. Now we come to the definition of another term that we call coefficient of frictional force, that is given a letter mu. Now this one is the ratio of frictional force to the normal reaction. Now for a body that is placed on a flat horizontal surface, the normal reaction R is equals to the weight mg, and therefore the frictional force or the coefficient of frictional force will be given by the frictional force divided by the reaction, which is where we are saying that Fr is the frictional force. When we plot a graph of frictional force against the normal reaction, this graph is a straight line through the origin. And if you get the gradient, where we know that the gradient is change in y over change in x, in our y-axis, we have the frictional force, and in our x-axis, we have the normal reaction. So we are taking the change in frictional force divided by the change in normal reaction. And that will give us what we call the coefficient of friction mu. Therefore, the gradient is equals to the coefficient of friction mu. Then from there, we have the types of frictional force. One, we have what we call the static or limiting frictional force. And this one is the force that is required to just start the motion, to just start the body sliding. So the force is directly proportional to the reaction force on the body by the surface. Therefore, our frictional force, or what we call the static friction force, will be equal to the mu, that is the coefficient of static friction multiplied by R. This is how we are getting the formula, because we are saying the force or the applied force is directly proportional to the normal reaction. So if we replace the sign of proportionality with an equal sign and a constant, then we find that Fs is equals to mu s R, where mu s is the coefficient of static or limiting frictional force. Then number two, we have the kinetic or sliding frictional force. Now this is the force that is required to keep the body sliding or moving at a constant speed, which implies that this force opposes motion between the two surfaces, and therefore the sliding friction is directly proportional to the reaction, which implies that Fk is equals to mu kr, where mu k is the coefficient of kinetic or sliding frictional force. Then from there we have that we can consider a block of wood that is pulled using a rubber band on a horizontal surface as shown in this diagram. You find that the rubber band stretches for some time, this one, before the block starts moving. And this stretch is due to the limiting frictional force. So you're pulling and the rubber band is extending. This one is extending due to the limiting frictional force. The stretching increases to a point when the block starts sliding steadily. In other words, we are saying the sliding frictional force will limit the motion. Therefore, we have that the coefficient of static friction is greater than the coefficient of the kinetic friction. But as you continue, this will continue until the body starts moving. So when you plot a pulling force against that time, you will find that the pulling force will continue increasing with time. And it will continue until the body is not moving. That is when we are saying that the coefficient or the frictional force is limiting the motion. The rubber band is just stretching. But when it reaches what we call the static friction force, or when we have that now the coefficient of kinetic friction is greater, then you find that the block will start sliding. Then from there we have that the laws of frictional force. One, the frictional force between surfaces or between two surfaces opposes relative motion. We have seen that because the work of the friction force is to resist, to oppose the motion. Then number 2, we have seen that the friction force is independent of the area of contact, which implies that if you have a block that have different faces of different surface area, the frictional force will be the same when you use different surfaces of different area. In other words, the friction force does not depend on the area of contact. Then another point is that frictional force is directly proportional to the normal reaction. And that is why we are saying F is equals to mu R, where mu is the coefficient of friction. Then another point is that kinetic friction is independent of the relative motion. And the next one we have that the friction force is dependent on the nature of the surface, which implies that if you have a rough surface, like sandpaper, the friction force will be high than when you have a smooth surface like glass. And this explains why when during the rainy season, when the ground is slippery, you'll find that you tend to fall because the friction force is less. Remember, friction force is very useful when it comes to walking. Therefore, if it is less, then walking is difficult. But if the friction force is high, then we have that it will enhance walking. So we look at advantages of friction force. 1, it enhances walking. It also helps in moving vehicles. Then braking, if you want to stop a moving vehicle, you apply brakes, and the friction also helps in braking. When you are lighting a matchstick, it is due to friction. Then we looked at the disadvantages of friction. We have that there is a lot of loss of mechanical energy in form of heat. And this one reduces the efficiency of the machine. Remember, whenever we have this friction, there is heat that is produced. In other words, the energy that could have been used to do some work is being used, or it is being converted to heat energy. That way, the efficiency of the machine is reduced. Then we have a lot of wear and tear of the moving parts of the machine. And this one now, it is disadvantageous because you have to keep on replacing the moving parts of the machine. From there, we need to explain the causes of friction. When you have two surfaces and then you view them using a powerful microscope, you will find that those two surfaces are not smooth. Why? Because we know that from the particulate nature of matter, we know that matter is made up of tiny particles. So even those smooth surfaces, there are tiny particles that are protruding. So when you view, you see those tiny particles forming tiny hills. So as you try to move along that surface, those tiny hills are the ones that are resisting the motion. And these molecules that are forming tiny hills, they stick together because of high pressure at those points. That way, you find that there is resistance, or there is opposition to the flow, or to opposition to the relative motion. Then from there we have the examples. Number 1, a smooth wooden block is placed on a smooth wooden table. A force of 14 Newton is exerted on 4 kg wooden block to keep the block moving at a constant velocity. So what is the coefficient of kinetic friction? We proceed as follows. F is equals to mu k R, where mu is the coefficient of friction. But we know R is mg. Therefore, we substitute the values. We have 14 newtons as our force, then mu k as our coefficient of kinetic friction. Then you get the mg. M is 4 and g is 10. So by multiplying, you get 40, and this is 14. So to get mu k, you have 14 divided by 40, you get 0.35. Part 2 of the same question is that if a 20 Newton brick is placed on the block, what force will be required to keep the block and the brick moving with a constant speed? So we proceed as follows. The coefficient of kinetic friction will remain constant because we are saying that we are moving with the same required constant speed. Therefore, Fk is equals to mu k. But now what is changing is the normal reaction. Remember, we have placed 20 Newton on top of this block that is having 40 Newton. So the total normal reaction will be 40 plus 20, and our coefficient is 0.35. So our force will be 0.35 multiplied by 60, which is 21 Newton. Then from there, we look at factors affecting frictional force between two surfaces in contact. One, we have the normal reaction. We have seen that the frictional force is directly proportional to the normal reaction. Then number two, we have the nature of the surfaces. The more rough the surface is, the higher the friction. How do we minimize this friction? We have several methods. One, we use rollers. For example, if you are moving heavy crates, you just place them on rollers and then they move easily. The rollers will prevent the two surfaces from coming into contact, and therefore the friction force will be minimized. Then number two, we use lubrication, and this is the application of oil or grease to the moving parts. Then we have the ball bearing. This one is applied on the rotating axles. Now the ball bearing allows the movement of the surface over the other. In other words, the two surfaces are not coming into contact. Then we have the air cushioning. This is where now the air is blown between the space between the two surfaces. This prevents, remember, air is a matter, and therefore it occupies some space. So this prevents the two surfaces from coming into contact, and that way we have that the frictional force is reduced. Then from there we move to viscosity, and this is the force that opposes relative motion between the layers of the fluid, or in other words, it is the frictional force that is exerted by the fluids. When we talk of the fluids, we are referring to both gases and the liquids. We are going to consider a small ball bearing that is introduced gently into glycerin along a cylindrical jar. The forces that are acting on that ball bearing will be the weight that is acting downward, that is mg, the upthrust. Remember, whenever you immerse any object inside a fluid, there is that upward push that we call upthrust, and then we have the viscous drag, or what we are calling the viscosity. So we have the three forces that are acting on that ball bearing. So the resultant downward force will be, remember, we want the resultant downward force because the object is moving downward. It will be the weight, which is mg, minus the total upward force. And the total upward force is u plus fr. And this resultant downward force is the one that is accelerating the ball downwards. Now, the viscous drag increases with velocity until the sum of the upward force equal to the sum of the downward force. So in other words, we are saying, as you increase, you will find that the viscous drag will increase. But when the upward forces, that is u plus the friction, is equals to the weight, then the velocity will be constant. That is, u plus fr is equals to mg. At this point, the resultant force is 0, and the ball attains a constant velocity that we call terminal velocity. So terminal velocity can be defined as the constant velocity that is attained by a body falling in a fluid when the sum of upward forces is equal to the weight of the object. In other words, we are saying, we have seen that the resultant downward force is the one that is accelerating the body. And whenever we have the acceleration, it means that the velocity is changing. But now we are saying the velocity will increase until a point where the upward forces will be equal to the weight. And at that particular point, then the velocity will be constant. It won't change. And that constant velocity that is attained when the total upward force is equal to the weight is what we are calling the terminal velocity. Therefore, when mg is equal to u plus fr, then the velocity of a body equals to the terminal velocity. From there, we can see it graphically here. The velocity is increasing with the time. But when the upward and the downward forces are the same, then that object attains a constant velocity, and that constant velocity is not changing, and that is what we call the terminal velocity. Then we look at factors affecting viscosity in fluids. One is density. The higher the density of the fluid, the greater the viscous drag, and therefore the lower the terminal velocity. That is why it is very easier for that ball bearing to fall in water than when you use a glycerin or a porridge. So whenever you are using a liquid of higher density, then the viscous drag, or what we call the frictional force or viscosity, is greater, and therefore we shall have a lower terminal velocity. So a glycerin has a lower terminal velocity as shown graphically here. This is the glycerin. It has a lower terminal velocity because it has higher density. This is water. It has a higher terminal velocity because it has less density as we compare the two. Then the second factor is temperature. Now, in liquids, the viscous drag decreases with temperature. That is, the terminal velocity increases with temperature, while in gases, the viscous drag increases. In other words, we are saying that the terminal velocity decreases with temperature. So in other words, we can say that in liquids, the viscosity decreases with temperature. Then from there, we have the assignment. Again, the assignment is testing what we have just learned. So read, revise, listen again, and then come and attempt the assignment. So thank you, and let us meet in our next lesson.